Hey everyone, welcome back. This is the sixth problem in the differential equations chapter of cracking the GRE math subject test. This problem is a little bit tricky. It's not so straightforward because we are told that there's this function little g, it's a real valued function, and it's part of this differential equation. And we're told that the solution to this differential equation, let's call it some function f, has the property that it passes through the point 1, 1. And then we're asked what other point it passes through, and we have to choose between one of the multiple choices. So the key to this problem is to recognize that this differential equation has the form of what's called an exact equation, and I'll give you a little reminder of what that is. An exact equation is an equation of the form m of xy, some function of xy, of x and y dx, plus some function n of xy dy equals 0. And the idea behind an exact equation is that if m is actually the partial derivative of some function f with respect to x, and if n is the derivative with respect to y of that same function, then the solution to the equation is that function equal to some constant. So the way to solve such an equation is to integrate m and with respect to x and to integrate n with respect to y. So that's what we're going to do here. Okay, so our m in this case is y plus g of x, and our n is x minus g of y. So let's take the integral of m. That's the integral of y plus g of x. That's going to be, with respect to x, forgot about that. And that's going to be xy plus the antiderivative g of x plus some function, let's call it h of y. We have to include that because when you take the derivative with respect to x, that's going to drop out. So it's like adding constant of integration, except here it's a function of y. And the same thing goes for n. We have to integrate n with respect to y. So we take the integral of x minus g of y dy, and that's going to equal xy minus the antiderivative of g of y plus some function, let's call it little f, of x, whose derivative with respect to y is 0, so we have to include that. Now when we look at these two solutions, then we see that this function of x is actually big G of x, and h of y is actually big G of y. So, or minus big G of y. So our answer is going to be xy plus big G of x minus big G of y equals some constant. That's going to be our the equation of our integral curve. Now, we are told that this curve passes through the point 1, 1. Well, the point 1, 1 gives us 1 plus big G of 1 minus big G of 1 equals C. Well, big G of 1 and big G of 1 just cancel out, and then you know from this that C has to equal 1. So the question now is, what other point can this integral curve go through? Well, let's look. 0, 0, the first option is 0, 0. Can this integral curve go through 0, 0? Well, if we put x equals 0, y equals 0, we get 0 plus g of 0 minus g of 0 equals 1. Well, g of 0 and g of 0 are going to cancel out, and then 0 equals 1 is impossible, so that can't be. Now, 2 and 1/2, well, 2 times 1/2, x times y, that's going to be 1. But then you've got plus g of 2 and minus g of 1/2. And we don't really know what g is. So we can't really say if that's going to work or not. And the same thing goes for c. d, -1, -1, yeah, x equals -1, y equals -1, so -1 times -1 is +1, plus g of -1 minus g of -1, that's going to cancel out, equals 1. Yeah, that works. So that answer does work. And then e doesn't work because you've got 0 times 1 plus g of 0 minus g of 1 equals 1, and we don't really know if that's gonna work or not. So the answer here is D.